Hi professors and teachers, thank you so much for devoting your time to attend my dissertation defense. I'm Yin Zhang, and my supervisor is Dr. Ernest. The title of my project is Extracting Respiration Rate from Single ECG signal. The content of my presentation includes 4 parts: scope, contribution, demonstration, and conclusion. First of all, the problems and motivation. Respiratory rate is one of the commonly used monitoring parameters in clinical medicine. In less developed countries, acute lower respiratory infection is a common cause for mortality in children. Respiratory rate monitoring can also be used for sleep apnea syndrome, which is a major sleep disorder. It can lead to repeated episodes of complete or partial obstruction of the upper respiratory tract during sleep. From 2003 to 2020, there were already 3 different kinds of respiratory illness outbreaking globally, which are SARS in 2003, MERS from 2014, and COVID-19 from 2019. As a kind of respiratory illness, respiratory rate monitoring is clinically significant during treatment for COVID-19. However, outside the ICU, respiratory rate is usually obtained by closely observing the chest of the subject, recording the breath. This counting chest movement method is inaccurate and inefficient. Therefore, we need to develop a kind of non-invasive, accurate, and efficient method to obtain respiratory rate with instrument monitoring and require no human beings to do it. According to the current situation, we need to develop a kind of algorithm to derive the respiration rate from ECG signals. This project aims to compare different ED algorithm methods with MATLAB and mimic database to find an accurate algorithm to derive the respiration rate from ECG signals. And the objectives of this project are to develop the ED algorithm from the different methods like baseline frequency modulation, amplitude modulation, etc., and extract the respiration signal and estimate the respiration rate from the mimic database with the algorithm. Then compare the results and evaluate the performance of different ED algorithms. Last, compare different kinds of electrodes from the perspective of shape, kneading method, material, and size. So a summary of contributions. In this project, we compared 5 different methods of extracting the respiration signal from the ECG signal method, which include baseline frequency modulation, amplitude modulation, QRS area, and EMD method, combined with 2 different methods of estimating the respiration rate from the respiration signal, which including breath cycle detection technique and Fourier analysis. Second, we tested all these EDR methods with mimic database. And the results from this project are like below. First, the algorithm extracted the QRS area from the ECG and estimated the respiration rate with the Fourier analysis method has the best accuracy. This performance followed by the algorithm extracted the baseline respiratory signal from the ECG and estimate the respiration rate with the Fourier analysis, and the algorithm using EMD with the Fourier analysis. Third, it shows that the Fourier analysis has a better performance than breath detectors in this project. Relatively, the performance of the methods using frequency modulation is worse. Okay, let me demonstrate the main part of the project. Firstly, the database. I used the mimic database from the website of FigBioBank ATM, which looks like this picture. When choose the record, for example, 041, we can download the data from the website. In this experiment, I choose 1 hour of the NAS and used 3 minutes from the 1 hour data and choose the ECG signal from the first or second lead. The data file looks like below. Every record includes 4 files. The first file with the .mat at the end is the data that we can use to test the algorithm. And the .info file includes the information of each record. For example, the record of 041. The second row of this data is the ECG signal from first lead. And the 7th row of this data is respiration signal. And the last file, plot atm.m, is the code that we can plot the waveforms of all the signal data in MATLAB. About the reference respiration rate, there are 2 different methods to estimate the respiration rate from respiration signal. First, breathing circle detection. Second, Fourier analysis. To decide the reference respiration rate, compare the results from automatic methods with the respiration rate manual counted from the respiration signal diagram, which is using the plot atm.m function to plot the diagram of respiration signal and counting the respiration rate during the time period we want. The mean absolute error of the breath detection method is quite larger than the mean absolute error of Fourier analysis method, so the Fourier analysis method is more accurate. Respiration rate estimated from a Fourier analysis method is choosing as the reference respiration rate. Next, the development of EDR algorithms demonstration. There are 2 basic parts of EDR algorithm. First part is extracting the respiration signal from the ECG signal, which including 5 different methods: baseline frequency modulation, amplitude modulation, QRS area, and empirical mode decomposition method. Second is estimating the respiration rate from the respiration signal, which including breath cycle detection technique and Fourier analysis. The next 2 slides illustrate the logic diagram of the different EDR methods. This is the demonstration of the code running. Here is the results from the experiment. Those are the IMF1 to IMF19 of ECG signal after EMD processing. This table shows the mean error and the root mean square error of different methods. From the table, we can conclude that the most accurate algorithm is extracting the QRS area from ECG and estimating with Fourier analysis. The methods of baseline window with the Fourier analysis and EMD with the Fourier analysis also have a very good performance. Improvement of the accuracy was noticed when using the Fourier analysis method rather than using breath detection in most methods. The worst of those methods are QRS area plus breath detection and frequency modulation with breath detection and frequency modulation with Fourier analysis. For the method of extracting the QRS area from the ECG and estimating the respiration rate with the Fourier analysis, the root mean square error is quite larger than the mean absolute error, which means some of the samples have a larger error compared with the mean absolute error. When analyzing the error of each sample, which showed in this table that the most inaccuracy of the result is sample number 214 and sample number 252, with the reference respiration rate over 15, which is relatively larger than other samples. And future work, we can research if the respiration rate will influence the performance of the EDR algorithms. Here come to the conclusion. This project compared the different EDR methods to calculate the respiration rate of ICU patients and found out that the method using QRS area plus with the Fourier analysis is most accurate. Furthermore, the method is in frequency domain like Fourier analysis to estimate the respiration rate is better than breath detection in most methods. This project also compared some different electrodes from the perspective of shape, kneading method, material, and size, which is in the chapter 2.7 in the report, not demonstrated in this presentation. So outlook of the study, the electrodes may influence the quality of the ECG signal. which may change the performance of different EDR algorithms. Hence, this can be one of the future work directions, and decide which kinds of EDR tools are better for EDR techniques.